discuss about response analysis. What is response analysis? Response analysis is how we describe a system, a system, a response system towards the outputs. Different system will behave differently with different type of outputs. One of the way to identify the system characteristic, the response analysis, is by determining the system order. What is system order? System order numbers representing storage energy component number in a system, or the number of characteristic root in a transfer functions. So for example, this one is we have this kind of system. In this system, we have the first system. We call it as first order system. Why first? Because it only contains one storage energy. What is the storage energy here? The storage energy here is the capacitor. For the second case, the second model, the second circuit, it also has one energy storage component. So we call it as first order system. Different with the third system, it has two energy storage components, which are the inductance and the capacitance. So we have two, inductor and capacitor, as energy storage components. So we call it as second order equations, second order system. And then, okay, what is response? Time response. Let's say if you have a tank here, and then we have flow rate here. So if you give the inputs, this one is time and this one is flow rate, the starting point is 0. It means the pump is off, and then you switch or turn on the pump, then the response will increase suddenly, and then how is the response here? How is the response here? It will increase slowly until it is steady. Right, this one is height, this one is time also. So we can call it as this area still when the pump is turned off, and then we can call this area as a transient condition, and then in this area we can call it as settling or steady state. Or steady condition. So this one is the response, yeah, system response. Especially if we discuss about dynamic response, yeah. How about a motor, like DC motor or one-phase motor or three-phase motor? Maybe will behave differently. Like this one, maybe the RPM will be fluctuated like this one. How about the damper? Yeah, you already discussed about damper. Oh, it will behave if there is like a different surface height, or you call it maybe an obstacle, or you call it polisi tidur in bahasa. How it will respond? The response will be some kind like this one, yeah. There is an oscillation or a dynamic here, the movement of m or ym, and this one is time. So this one we call it as system response. In the next slide, you will learn about how we can. You will learn about how we identify or describe the system response in terms of several terms. Okay, the first thing we need to learn is about how we define first order system response. I just want to remind you that what is the first order? First order is a system with only one energy storage. For example, like RC circuits and also tank system. This one is only one. It only has one energy storage or storage energy. Then we call it first order system. In terms of transfer function, it will have tau s plus 1. And then let's discuss about the system response. First order equation, we have this term, time constant. Time constant, yeah. What is time constant? Time constant is the time or the duration needed for the system to reach 63% of the system response. For this case is 100%. So to reach 63% of the response, it needs this time constant. Then it will settle at 4 times time constants. And then this one is time constant. It's only for step response, yeah, step response. What is step response? If the input is like this in the previous case, on and then off. I mean off and then on. That's the time transient response. In here, we will learn about several terms to define transient response. In bahasa, term is istilah, ya. So we have several terms. If we want to like describe this kind of response, and then the one of the terms that we usually find when defining a time response is overshoot, the maximum overshoot. What is overshoot? If we like define a target, like in this case is 100% or 1, and then the response is more, the response value is more than what we targeted, exceeds than 1. This one is overshoot. So sometimes more is not so good. And then we have delay time. What is delay? So you can see here, it is a kind of delay. The form can be different. Maybe delay is like this one, and the delay can be like this one. So like the gradient is decrease slightly, or not decrease, yeah, the form is like this one. Okay, and then we have rise time, peak time, and then one of the most important thing is settling time, when the response is steady or within 5% or 2% of range. The steady time, the settling time can be like this one is transient, and this one is settling time. Okay, and it is example, maybe in several cases we already define like the time delay and then the maximum overshoot and then the settling time in several cases, not usually, but several cases. Okay, I think enough for this video. We will move to the how, if we want to identify the first order system time response.